Bismillahirrahmanirrahim. Sallallahu ta'ala ala Muhammad sallallahu alayhi wa alihi wasallam. Boys, our lecture today, our lecture about the theorem 3 of chapter 11, class 10th, 11.3 theorem. In this theorem, the questionnaire says that equal cards of a circle within a bracket written that are of congruent circles, and means equal cards of congruent circles subtend equal angles, right? They subtend equal angles at the center of the circles, right? Circle of center पर equal angle subtend करेंगे. Let's see what we have given. This is our card AC and this is our card A prime, C prime. These two congruent triangles, right? These two congruent triangles. We have two congruent triangles. So what is given? A, B, C and A prime, B prime, C prime. A, B, C, A prime, B prime and C primes are two congruent circles with centers O and O prime respectively, right? Respectively, so that what is another thing that is given? AC, the card AC is equal to A prime C prime. The card AC congruent to the card A prime C prime, right? AC card is congruent to A prime C prime. This is our given. What we have to prove? We have to show that the central angle AOC is congruent to A prime OC. This is basically converse of the theorem 1 by 1. So we can say what we have to prove. To prove angle AOC that is congruent to the angle A prime O prime C prime. What we have to prove? AOC, this angle AOC is congruent to the angle A prime O prime C. Both are the central angles if we consider it as an arc AC and A prime C prime. If these are two arcs, then they forms two central angles, right? AOC and A prime O prime C prime. What is the construction steps here? Let's see the construction steps, boys. Let it be possible that major angle AOC, that we have to suppose that major AOC is not congruent to A prime O prime C prime and it is congruent to some another point. So let's take another one point. And this point is known as D prime, right? This point is known as D prime. Let's suppose that if possible major angle AOC that is not equal to major angle A prime O prime C prime, then we have to consider it. Then consider angle AOC that is congruent to angle A prime O prime and the D prime. A prime O prime D prime. This is the point which is you can say less than C, right? Smaller than C, right? Now we have to prove it with the help of statement and reasons. Statement and reasons. What about the statement and reasons? In the constructions we say that angle AOC that is congruent to angle AOD, A prime O prime D prime, right? That is our construction. This is our construction. it's whenever we say that the angle AOC congruent to the angle A prime O prime D prime, right? This angle AOC is congruent to angle O prime. Whether already we have given that both the circles are congruent, then it's mean that their arc AC must be congruent to A prime D prime. Definitely. Are subtended by equal central angles in congruent circles. The reason the circle was congruent, right? When we say the central angle are congruent, it's mean that their corresponding arc must be congruent. So, sorry, this was arc, no, not the chord. This was an arc. Fine. Arcs subtended by equal central angles in congruent circles. In congruent circles. And again the statement and reasons. Right. If we consider, as we have supposed in the construction step, that the angle AOC congruent to the angle A prime O prime D prime, so according to AOC, this is angle congruent to A prime O prime D prime. So according to this arc AC and A prime D prime, these both arcs definitely become congruent because if the central angles of congruent circles are congruent, then their corresponding arcs must be congruent. So according to this, we say that this is equation 1. I notate it by equation 1 and know the equation 2. Measure angle AC, that is measure side AC is equal to measure side A prime D prime, and this side is known as chord. According to theorem 1, if the corresponding arcs are equal, then their corresponding chords must be equal. So when we say that the arc AC and A prime D prime, these two arcs become congruent, then their corresponding chords definitely become congruent, and the reason is by theorem 1. By theorem 1, you have to write the statement. You have to write the statement. What was the statement of theorem 1? That is the corresponding, you can listen it again. If the two arcs of a circle are congruent, then their corresponding chords are equal, right? Their corresponding chords are equal. If the arcs are congruent or equal, then their corresponding chord definitely become equal. But this was our equation 2nd. But why we write the but? Because measure AC, the side measure AC, that is equal to measure A prime C prime. This was a given. You can see this was a given. Look at the given. What is the given? Where was it? Was a given. And this was a statement. I am highlighted in the box. A prime C prime and AC both are congruent. So this is our equation 3rd. So equation 3rd, by using the theorem 1, we have said that AC and AD are congruent, but in the given we say that AC and A prime C prime both are congruent. So according to 2nd and 3rd, if we consider 2nd and 3rd, from the 2nd and 3rd, definitely we can say measure A prime C prime, this chord is equal to measure A prime and D prime. So you can see if AC is congruent to AD and AC congruent to A prime C prime, it means both have become equal, and this is from 2nd and 3rd, right? Look at this now. Which is when it is possible, when say that AC and D prime, AC is congruent to A, we say that AC congruent to AD, this chord AD, right? When it is possible, It is only possible when the points C and D coincides, right? Which is only possible if C prime coincides with D prime, right? Hence, we can say Mayer angle A prime, O prime, C prime equal to Mayer angle A prime, O prime and D prime. This was equation 4th, right? But when this is possible, it's mean that Mayer A prime, O prime, C prime, A prime, O prime, D prime both become equal, right? But we can say that Mayer angle A O C, that is equal to Mayer angle A prime, O prime and C prime, A O and sorry D prime, right? This is equation 5th. Mayer A prime, O prime, C prime, that is equal to Mayer A prime, O prime and D prime. But what do we say? Why we write it? Mayer angle AOC is equal to, this was a construction because this 5th, because of construction, right? Because of construction step. So it's mean that this implies that Mayer angle AOC must be equal to Mayer angle A prime, O prime and C prime using 4th and 5th, right? Using this 4th and 5th, when we say from the previous one conditions, hence Mayer angle A prime, O prime, C prime is equal to Mayer angle A prime, O prime, D prime. Why we say this? Because we say the card both the cards are equal. Mayer A prime, C prime equal to Mayer A prime, D prime. When these two cards become congruent, then their corresponding center angle must be congruent. So A prime, O prime, C prime equal to Mayer angle A prime, O prime, D prime. This was notated by the equation 4. But in the construction step, we say that Mayer angle AOC must be equal to Mayer angle O prime, A prime, D prime. Why we say that? Because in the construction step, we take this A, D prime and we say, look at this. This was the construction step, no? Mayer angle AOC is equal to Mayer angle A prime, O prime, D prime. This was the construction step, right? Fine. So according to, and we notated with the equation 5th. So from 4th and 5th equation, we found that Mayer angle AOC must be equal to Mayer angle A prime, O prime and C prime. So this was our required theorem. Also guys, try to, you will understand it. Inshallah, wish you best of luck. Thank you.